and this video is the first of two videos for section 3.3 in the Honors Algebra 2 textbook. We are working on composition of functions. The idea of composition of functions is we are going to use two functions kind of together to find the value of something. Let's start with a warm-up to really get the idea of what a composition of function is. I have a table here. You are going to use two functions to complete the table. So in your notes, please copy down y equals 3x plus 1 and z equals 2y minus 3. In the table, I have x values of -1, 0, 1, 2, and 3. And my goal is to figure out what all of these z values are. So when I get started, if I know that x equals -1, well, can I plug it right away into my z function? I can't because there's no x in the function to plug it into. So I look at this first one and say, oh, right here, I have an x to plug in and that will give me my y value. So we might as well start there. So every time I see an x, I put in a -1. So it looks like, oh, y must equal -2. That is correct. Now, am I ready? Do I have the information I need to find the value of z? Now I do, because when I look to find z, I needed to know that y was -2. It looks like z is going to be a -7. I want you to pause the video here. Yes, actually pause it and finish filling out this table for when find the z values when x is 0, 1, 2, and 3. Pause, fill out the table, and then join back in. Actually pause now if you haven't yet. Do the work. All right, I'm hoping you've come back from a little pause now and you've gotten in this routine. When x equals 0, in order to figure out what z is, you had to first find that y was 1, and then you took that answer and plugged it into a new equation and got z to be -1. When x was 1, you plugged it in to find y. You took your new answer to plug it in to find z. When x was 2, you plugged it into the correct equation to find y. You took that new answer of 7 and plugged it in to find z, which is 11. And then lastly, what started with x equaling 3, you plugged in to get y to be 10. You use that new answer to find your final one to get z to be 17. That is the idea of composition of functions, is we started with a value, and to get to our final one, we had to take like a middle step. We couldn't jump right from x to z. We had to stop and find that value of y in the middle. So a composition of function is you use one function before you use a second one to get your final answer. That's the idea of what's going on with the composition of functions. Composition of functions, they're written kind of in an interesting way. This right here is notation for composition of functions. To say that out loud, I would say you need to find f of g of -3 is how I would read that out loud. The second one I would say out loud, I would say, oh, g of f of 2 is how you would say those. Those parentheses are really what gives you a clue that you have a composition of functions going on. It's like you have a function within another function. Honestly, there are a lot of different ways to solve these to kind of do that work that the table did on the last slide. You have to find what works for you. Personally, what I like the best is to work the inside out. So I'm going to start with finding the value of g of 3. And it always helps me to think of that number, or g of -3. That number way inside the parentheses, -3, that's the value of x. So that's like the starting point on this table. It gives you that value of x where you start. So in the second example, x will equal 2, okay? And then if we work inside out, starting with g of -3, what's that it's telling you to do is use the function g of x. But every time you see an x, you put in a -3 instead. So I'm personally going to rewrite this. I'm going to put f with big parentheses so I don't forget that this guy is out there. But now in the parentheses, I'm going to evaluate what g of -3 is. So that goes right here. Well, g of -3, every time I see an x, I replace it with a -3. So if I simplify that up a little bit, I get f of -2, because -3 plus 1 is -2. That -2, that's like that middle answer. That's kind of in the middle of the column now. It's not our final answer. It's not the one we're looking for, but it is a definite necessary piece of information to get to our final. So now that I know that f is -2, I evaluate. Well, what is f of x? Well, that's this function over here, and it's defined as 2 times x. So to solve that now, every time I see an x, I replace it with a -2. So my final answer here is -4. I would officially write that as f of g of -3 equals, sorry, I ran out of room there, -4. So it was like the -3 was what we started with. We solved that to get that -2. That was the middle answer, not the final answer, but it got us to the final answer of -4. So those would have been the 3 numbers if we had done this table style like the last slide. So let's try this one. G of f of -2. I'm going to pull these guys down. G of f of -2, we're going to work inside out, or I'm sorry, not -2, a regular 2. We'll work inside out. The 2 is our starting value, and we're going to have to do 2 steps to get to our final value. I'm going to start inside out by finding that value of f of 2. I am going to write a g with big parentheses so I don't forget to do that. Well, what is f of 2? Well, that's going to come from this guy. So every time I see an x, I'm going to put in a 2. Well, 2 times 2 is 4. So 4 is like that middle number. It's not the final yet, but it is very necessary to help me get to the final. Well, g of 4, that wants me to use this function then, g of x, and every time I see an x, I put in a 4 instead. Just in case you missed that, because g of x is defined as x plus 1. So since we were doing g of 4, every time I saw an x, I put in a 4, and I ended up with g of 4, that's going to equal 5. So my official final answer here is g of f of 2 equals 5. So that is the idea of a composition of functions where you start with 1, we got our middle guy, our helper 4, with our final answer of 5. So those would have been like the 3 answers in the table from the first slide. Let's try another set. Now I have y of x equals x plus 10 and c of x equals x squared minus 1. I called the first example mild. I'm calling this one medium. It's really no different except that c of x has an x squared. It's a quadratic, so you just have to be a little more careful with your math is all. So here, c of y of -5 is how you would say that first one out loud. To set up the work, to work inside out, I'm going to do c with a big parenthesis so I don't forget about it. But my first step is definitely to evaluate that y of -5. Since it's y of -5, I'm going to use the y of x function. And every time I see an x, I'm going to put a -5 in instead. So instead of x plus 10, I'm going to do negative 5 plus 10. And when I simplify that, negative 5 plus 10 is 5. So now we're halfway there. That 5 is, again, it's that middle answer. That's not the final answer, but it's totally necessary to move forward. So now to solve for c of 5, I'm going to use the c of x function. And every time I see an x, I'm going to replace it with a 5. So instead of x squared minus 1, I'm going to do 5 squared minus 1 and simplify. Well, 5 times 5 is 25. 25 minus 1 is 24. So my final answer for this one would be c of y of negative 5 equals 24. So negative 5 on our table was our first answer. Positive 5 was the second one, but 24 is the final answer that you care about. If you want to pause and try the second one on your own before you watch me do it, you certainly can, or just continue following along, taking excellent notes, I'm sure. All right, so this one I would pronounce y of c of negative 5. I'm going to write the y with parentheses, so even though I work inside out, I won't forget that second step of using the y. But I will start by evaluating c of negative 5, so that will go into this function. Every time I see an x, I put in a negative 5. Well, negative 5 squared is still a positive 25, so I get y of 24. Remember, that's that middle answer. Negative 5 was the first value in the table. 24 is after evaluating the first function, but now to get what I really want, I take my new answer, and it's y of 24, so it goes into the y of x function, and instead of x plus 10, I'm going to say 24 plus 10, and get 34. So that is the third number in my table. Oops. Try that again. That's the third number in my table, and I would write my final answer. Oh my, things are getting exciting. I write my final answer. Still not going to work. Let me try again. There we go. As y of c of negative 5 equals 34. All right, that is the end of the first video. Please do not skip the second one. It has a lot of helpful things for you. So stay tuned. See you in a minute.